Hello, I'm Chase Thompson, and this is my HIP Symposium presentation on colony collapse disorder in honeybees. Colony collapse disorder, or CCD, is a condition where the majority of worker bees in a honeybee hive just disappear suddenly and without an apparent reason. Factors that contribute to this include climate change or pesticides or parasitic infection throughout the hive. Um, this condition serves to create instability in honeybee hive populations. And because of this, it's a great importance to the agriculture industry and food security at large. And because of that, it has been the topic of much research. To get to the bottom of CCD, the contributing factors that I mentioned before have been widely investigated, but and researchers are yet to find one conclusive reason for CCD. In this research, as I mentioned before, it is largely external, and there's been a lack of attention on the internal hive dynamics in trying to solve this issue. The question I aim to solve in my research is that since external factors such as pathogens in the environment have been shown to contribute to CCD, is there something that's overlooked in internal factors in hives that contribute to this also? And my hypothesis is that hive dynamics related to population density in honeybee hives is a significant consideration in explaining CCD cases and susceptibility. In researching my hypothesis on whether population is any form of indicator for CCD, I have discovered a graphical model that was developed. To begin the development of this model, the mortality and uh, population increase rate in a hive was determined, as you can see on the top right graph, where there are two critical values where the mortality in the dotted line is meets the population increase rate in the solid. And this graph was produced and according to a number of factors. These include the rate of egg laying and the recruitment of larval bees to worker bees and their ability to forage. And changes in these parameters will change the position of or excuse me, just flat out the population increase rate and the mortality rate, so that a change in this parameter might cause a hive that sits comfortably in this range where the population increases more than it dies off into a range where it now is no longer feasible. This population graph and the parameters were then used to create a potential function which represents the stability of the system. For potential function, the stability or the kind of wider and steeper, excuse me, yeah, steeper the function is, the more stable it is. And as you can see on the bottom right graph, on the very bottom line, there's a wide basin of sorts. This represents a hive undergoing favorable conditions where the lines above it are progressively less and less favorable, and it becomes less and less stable. The results of this research produced a dynamic model for the influence of population density on honeybee hives and to determine an upper and lower critical population count for honeybees according to factors. Subsequent studies additionally demonstrated the influence of population density in other eusocial or hive insect species, namely ants. and verified similar population-based models to estimate their hive feasibility. In conclusion, population-related dynamics are a promising avenue to gain further understanding of a hive's susceptibility to colony collapse disorder. However, the issue of CCD remains multifaceted. The factors that alter the model or parameters are ultimately the same, are known issues that I mentioned previously. Um, helpful as helpful of a tool as this model might be in kind of diagnosing the hive susceptibility to this issue, it doesn't solve it per se. And here are my references to this presentation, and thank you.